All right, in part 5, we're going to be looking at conditional statements and control flow. So let's just dive right in. We can say, for instance, is 50 greater than 100? And that's one thing to know about these comparisons is that this is not a statement. It's more so a question that Python will answer, and it will answer false because 50 is not greater than 100. So this is a false statement. So 50 greater than 100 is false. What about 50 less than 100? Well, that would, of course, be true. Now, we can also do less than or equal to or greater than or equal to by typing it almost like we would say. We would say less than or equal to. So put the less than first, then the or equal to. And now we get a true out of this statement. But that or equal to is crucial because without it, in this case, we would get a false. So you can, again, do your greater than or equal to or less than or equal to by putting in the or equal to second after your greater than or less than symbol. And we've got two more of these to look at, and there are the double equals. So we could say, is 400 equal to the string 400? And that would come out as false because this double equals is comparing and saying, are you exactly the same? And so one big thing to know in Python is that a number, whether it's an integer or a float, cannot be equal to the string version of that same value. So they look very similar, but when you compare any number to a string that looks similar to the number or any string in general, you're always going to get false out of that. Now, just as a finer point, if we compare the integer to its float, now that will be true, so that makes sense there in that sense. But yeah, comparing any sort of number to a string, that's always going to come out as false. And we could be checking also if something is simply not equal to something. So is 400 not equal to 100? Well, that's a true statement. So not equals is exclamation point equals. One last thing to say there is, well, what about the single equals? Why are we not using that? And that's because don't forget that we've been using single equals as the assignment operator is technically its name in Python. So this is what we use to say, okay, I now want my string, this variable name I'm just making up out of nowhere, to be equal to or assigned to whatever I want afterwards. Now, we don't have to just compare values. We can also compare strings. So we could also use our variable names in our comparisons. So we know my strings is equal to capital E eggs. We could say, is that equal to lowercase eggs? And the answer is false because it needs to be an exact match. So now, is my string equal to uppercase eggs? Yes, it is. That's exactly what it is. Is my string greater than 400? That probably doesn't make much sense. Yeah, we'll probably even get an error because we can't even do that comparison between a string and an integer. So we can definitely get some errors here. And really, we're just trying to show you a bunch of different scenarios of things that might come up in your code. Like you might accidentally, like here's one thing you might want to do. You might have wanted to compare, is this equal to all lowercase eggs? Like maybe you weren't sure if it had capital letters, and maybe instead you forget to put that double equals, and you've now just reassigned my string. You haven't checked whether it's equal to capital E eggs. You've reassigned it to lowercase eggs. So be careful for double equals for comparisons and single equals for reassignment. Okay. I think that does it about for our comparisons. Well, maybe we'll do one more really, really quick. You can also compare lists. So we could say, is the list 234 equal to the list 432? And that's going to spit out false. Now, why is that going to spit out false? Because remember, lists are ordered. So because these contain the same elements, but they're in a different order, we're actually going to get false out of this. So what if we switch this around and had them both in the same order? Now we get our truth out of that. Now, what about the very last one we'll look at here is dictionaries. So what if I said that I had, needs to be a string. Once again, apple equal to 7, and I think we did what? Pair equal to 3, or pair key value 3. And let's type this in reverse order. And hopefully you know the answer to this if you remember what we did last time when we discussed lists and dictionaries. What do you think this one's going to be and it actually spits out true. And again, remember that's because dictionaries are unordered. They're just known by their key and value pairs. So these two dictionaries, even though the way that the items were put into them in a different order, after you've made a dictionary, the order does not matter. And when you put the values in doesn't matter. As long as they contain the same key value pairs, they're equivalent in their dictionary forms. So I think that covers it just for about all the comparisons or any others, explore around and play with simple examples. And really, that's what I end up now using Jupyter Notebooks for. Hey, wait, do dictionaries care about their order when I want to compare them? Oh, no, they don't. Just use a simple little example that you make up, and now you kind of remembered that rule. Okay, so that's kind of part one of this video. Part two is dealing with logical flow. So we're going to learn about if, elif, and else statements now. And sometimes we call this control flow because in real life, what you're going to be doing in your programs is you're going to be taking user input and validating that it meets some criteria. Like the simple act of creating a password, you have to make sure it's a certain amount of characters. You have to make sure it contains a capital. There's conditions or control flow that you need to manage to make sure the user did something right. If they did something wrong, you need to send them back to try again. If they did something right, they can proceed to the next page. And so even though this is a silly little example, the idea of control flow is really where programming truly begins, understanding what are the hoops that someone needs to run through to make this program work functionally for them and make intuitive sense for them, or to make sure I'm getting the correct data out of whatever I'm throwing stuff into. That's what control flow is all about. So in Python, we can for me, I just thought about a silly example of someone going to the movie theater. And let's say we've got an 11-year-old going to a movie theater, and they want to see a movie that's rated PG-13. So what we could do is we could say if that person's age is greater than or equal to 13, we can print go enjoy the movie, right? It's PG-13. They should be over 13. I know we don't really care about ages for PG-13 movies now, but go with me for sake of example. What happens here is I ran this code and there should be a print statement, but we didn't see anything. And maybe that's surprising, but hopefully it's not too surprising because this print statement is indented underneath this if statement. So maybe let's backtrack really quick. First, we just introduced this if, which is in purple, so that's some new highlighting to show you, hey, you're using some different aspect of Python now. You're using logical control flow. You're using an if statement here. Now, an if statement has to immediately be followed by some sort of comparison or some sort of really Boolean value, right? Like this has to be some Boolean value. So what we're really after is if something is true or if something is false. Now, if that something or if that Boolean logic there is true, then this indented line will get ran. And you could have as many indented lines as you want underneath here. You could have a whole different section of code that opens up once you get into this if statement. But the only way you get into this indented line is if, again, this condition is true, if the condition after the if is true. Now, also, your condition after you type it out, you need a colon, and usually your programming, software, whatever you're using, will automatically put that new indented line underneath, and it's up to you to say, okay, I'm done with my if block, and press delete, I'm now out of it. Now, besides that, we had nothing print in this code because, well, again, this condition was not met. Age is 11, so is the age greater than or equal to 13? No, it's not, so we never went into the indented line to do the code inside here. Well, what if we did want to say something? We could say else. So else means, well, okay, if this condition wasn't met, then literally anything else will now happen. So if you did not meet that first condition, we could say, sorry, you're not old enough. And hey, look, there's a little reminder that if you want a single quote in your strings, you're going to have to wrap it in double quotes all the way through. Now when I run this code, I do get sorry you're not old enough, again, because the criteria was not met in the initial if statement. So it then says, well, I'll go to the else statement and execute. So if the if statement's true, let's make that happen here. If the if statement is true, then we'll say go enjoy the movie, and we'll never get to the else portion or else kind of block of this conditional logic. And if the if statement is false, then we won't read into this line and we'll move on to the else block. Now, you can also have more conditions inside of these ifs and elses. You don't just need if this or else. You could also have what we call an elif statement. So maybe we say elif their age is greater than 10. We'll say, okay, just this once, right? So maybe you're saying, all right, you're not old enough, but you kind of look old enough. I'm not really going to ask for ID or whatever. So now I get, okay, just this once. So you can see, again, the if initial condition was not true, so we did not enter into this indented logic. The elif then said if your age is greater than 10, so we did go into this indented logic. And because we found a truth out of this if, elif, and else block, now we know to not worry about anything in this else block because we already met a true condition. So anytime you have like if, elif, else, one of these block chains, not blockchain, but you get what I'm saying there, one of these logic chains here, only one of them can occur. And once one of them has occurred, everything else underneath will be ignored. So we could go further with this. We could say elif the age is greater than 5. We could just say I don't think so. All right, so let's hear. You weren't greater than 13. You weren't greater than 10. Let's say you were 8. So now you're going to say, I don't think so. Again, we met that logic chain there, so we never got to the sorry you're not old enough. So last thing would be, I don't know, a 2-year-old, and definitely sorry you're not old enough there. Now, the other thing about this simple little logic here is that what's definitely going to matter is the order I wrote this in. I was kind of being clever here because I was using some sneaky logic by saying, okay, I know if you're older than 13, this is going to happen first so we can ignore everything else. I kind of have my logic flow going in age order from oldest to youngest, and that definitely matters because if we print or if we switch these two, the elifs, if we switch them now and I've got a 11-year-old, notice you're going to get I don't think so. And we probably were trying to say, okay, just this once, right? So we got age is greater than 5, and that happened first in the logic chain before age is greater than 10. So we got this printout, and now we're not getting this one. So the order of your if and elifs and elses definitely matters. Also, again, just to say out loud or just to review, you don't need elifs or elses. You can simply just have one condition, and hey, if it's not met, then it doesn't go into the indented block. Now, what else are we going to do in our programs? Well, sometimes there's going to be code, not sometimes, probably all the time, there's going to be code that happens after your if, elif logic kind of block. So we could always just say, have a great day, no matter what. So even though they weren't old enough to go to the movie, we could still tell them, have a great day. And we could also, again, say print, enjoy the movie if they're old enough. And then have a great day will still happen afterwards, right? So that can definitely happen as well. There's probably going to be some stuff that happens after your if-else logic, and all of that will be executed regardless of which indentation you got into based on the truth or falseness of your conditions. Now, we can also even put in other if-else statements in the middle of our if-else statements. So let's say they were greater than 13. So then afterwards, I could say maybe if, what do I want to say? If age is greater than 40, we could say, would you like popcorn? I don't know why we're just caring about that for 40-year-olds. And then else, we could say print, would you like candy, right? So now if I have someone who's 30 years old, it's going to say go enjoy the movie, right? Because that first if condition was met, age is greater than 30. Now we're into these two conditions and only one's going to be true. So is their age greater than 40? No, it's not. So we didn't ask would they like popcorn. So we got to the else block and said, would you like candy? And then we also didn't get into this else block because we already met the age is greater than 13 condition. And finally, we go to print have a great day. underneath. So you can have nested if-else statements in your logic, and that's something that might make sense. So maybe a place where this makes sense is we could say their age is 30, and let's say the amount of money they had was 20. And so we could also do some other stuff here, like we could then check for price. So we could say if age is greater than 13 and money is greater than 15, because let's say, or equal to 15, because let's say that's how much the movie cost, we could say print go enjoy the movie, and then print your change is, and this is where we're going to introduce some extra kind of like programming into this. We could say your change is, and we could say that I want the string of their money minus 15, because we're kind of just based on this logic assuming that a ticket must cost $15. All right. Now let's see here. If their age is greater than 13, and let's say they did not have enough money to go, so let's copy that. That's going to be an Elif. So what if you're greater than 13 and you have less than $15? Then we're going to say, sorry, you don't have enough to go. All right, so let's see here. They're 30 years old and they have $20. So we say go enjoy the movie. Your change is 5. Have a great day. So notice now we've got like 2 conditions that we're juggling. Now, what if they're 30 but they only have $10? Then, sorry, you don't have enough to go. Still have a great day. So we can have multiple conditions that we have to satisfy in our if-elif logic here as well. So I think we've covered just about all of it now that I think about it, right? We've got ifs. You can have as many elifs as you want. We've got a lot more scenarios in here. We could say, again, elif, what if their age is greater than 10 and their money is greater than or equal to 15? And maybe we could actually have different pricing here. Like if maybe that's what makes sense. Maybe if they're over 50, right? Usually there's a discount, so maybe they only have to pay $10 to go to the movie instead. And let's see here. We should set that to 50 then. And what if their age is greater than or equal to 13? And you've got more than $15. Well, now we're going to print this logic here. But again, that costs 15. Oops. Seniors only need $10. So you can kind of see the more you play around with this and the more you add stuff in later, the more you might have to go back and copy and paste and switch some things around. So be careful with that. It can definitely get a little bit tricky to remember what you've changed. And also, we'll find better ways to write these in the future. Like there's probably a better way to structure your logic than have this written out multiple times, like 50 and 50 and 10 and 10 and 15. But we're just here to learn the basics of the if-elif logic. So let's see here. We also, that ticket's 15. I think we got it. So, yep, they're 30 and they have $10. They don't have enough money to go. Now they're 30 and they've got $20. Again, go enjoy the movie. Their change is 5 because the condition that was met here was this one, right? They were greater than 13 and they had more than $15. So they were able to go to the movie. And finally, let's say we had a 60-year-old. Then you can go enjoy the movie and your change is 10 because, again, they only had to pay $10 for the ticket. If they have $10 exactly, then their change is 0, so on and so forth. I think you get the idea. So we've covered a lot in this video. We've covered that you can have if statements. They don't need elifs or elses, but if you are going to have them, your elifs need to be in the middle, and there needs to be, there doesn't need to be an else at the end either, right? You don't have to do that. But an else must go at the very end of all of your logic. We also discussed that you can have ifs and elses inside of another if-else block. You can kind of nest those like we did earlier in the video. And of course, you can also have more than one condition that you're checking for in your if-else logic as you go through it. Just be careful that you try to cover all conditions carefully. And also know that the order that you write your if-elses in matters, because if you're doing it based off of like some numeric value, you want to make sure the order makes kind of logical sense for what you're going to encounter first. And in the next video, we're going to be covering while loops and for loops, and that is where we're really going to see programming really start to shine, and we're going to move from just kind of understanding Python, and we're going to really dive into, still understanding Python, but more so getting into the power of what coding languages and computing can actually do for us. So that's going to be really exciting. I'll see you then.